In this video, we shall use the circle theorems which we have learnt in the earlier video to solve some of the ICSE exam questions. So, watch the video till the end so that the exam questions on circle theorems don't make you go in circles and you don't get a circle as your mark. So, like, share, comment and subscribe to my channel. By now, you must have finished solving the questions on circle theorems from your textbooks with the help of your teachers. Now let us look at some of the board exam questions. Every year, about 7 to 10 marks are from this topic. Let us look at our first question. This question is from 2018 ICSE board paper and this is question number 2C, which means it is from section 1 and that is the compulsory section. PQRS is a cyclic quadrilateral. PQRS. QPS is 73. PQS is 55 and PSR is 82 degrees. Calculate angle QRS, RQS and PRQ. Now let us draw the diagram. The first thing that we need to do over here is to write what was given, which means the angles QPS was given as 73, then we have PQS was given as 55 and PSR was given as 82. Now we have to find QRS. QRS. We'll call that as angle A. We have to find that. RQS. RQS. We'll call this as angle B. And PRQ. PRQ. So we need to join this and PRQ here. We'll call this as angle C. Now first thing we have to understand is the circle has PQRS on its circumference. So PQRS becomes a cyclic quadrilateral. Do you remember the theorem connected with cyclic quadrilateral? With the angles which are opposite to each other, they will have to be supplementary, which means 73 and A will have to be supplementary. So how we will write this? Now this is our thinking step. We will say A plus 73 equal to 180 degrees. And so your A will be 180 minus 73, that will be 107 degrees. When we look at this B, we have to see what is B a part of. B is part of this triangle. Now we have to find B. We know this angle is 107, but we do not know how much is this angle. So we look at another possibility. Can you see B is part of this angle PQR? 55 plus B is angle PQR. And this PQR can be connected with this 82. Again, we will say that the opposite angle, that is S and Q, they are supplementary. And so what we will say that 82 degrees plus Q means 55 plus B. And that will be equal to 180 degrees. So we have 137 plus B is equal to 180 degrees. And your B turns out to be how much? Correct? Are you getting this? Alright. So now we have to look at our C. How do we look at this C? Now C is connected with angle QRS. This full thing is 107 and this is part of that 107. Can you see that? So can I possibly find this angle? How will I find this angle? I will have to look at the end points of this angle. Starting from vertex R, let us look at the end points S and P. Can you see? We are going this way and this way. And so we get which arc? PS. Now PS is also subtending this angle over here, 55. So SRP and SQP, they are angles in the same segment. So this also becomes 55. And then we will say C plus 55 is equal to A. Can you see this? And so we will have C plus 55 is equal to A, which is 107. C will be equal to 107 minus 55. So we have found A, B and C. Now we have to write this neatly. Let us see how we write it. Let us look at our solution. We have written this down. Now since this is the first question, I'll explain it to you how we wrote it. So we started with angle P plus angle R. These two, they are opposite angles of the cyclic quadrilateral. So they will be supplementary, means if you add them, you will get 180 degrees. We write the reason like this. Now we substitute the value of P, which is 73 degrees, plus R as it is, and R will be 180 minus 73 degrees. And so angle R means angle QRS, and that is 107 degrees, and that's your answer 1. Now remember the steps that we've taken for B. Now we take angle Q and angle S. These are the opposite angles. So can you see over here, Q plus S angle is equal to 180 degrees. It's exactly the same reason. So I put the ditto marks. Now Q is 55 degrees plus B. So I've written B plus 55. S is, full thing is 82. So connect what is known with what is unknown. That is, remember, the first and the foremost tip for this. So that is 180 degrees, and B will be equal to, you add these two. So you will get 5 and 2, 7, 8 and 5, 13, 137 equal to 180 degrees. So angle B is equal to 180 minus 137, which is 43. But angle B is RQS. So we write angle RQS, and that is our answer 2. Now we come to the C part. C, we are connecting this A with this full thing. C plus 55 is equal to A. So we have to first write this is 55. Why this is 55? Because PQS and PQR are angles in the same segment. So we've written just that. And now we will write angle QRS is equal to this plus this. What is this angle? PRQ. See this? And plus this angle, which is PRS. Can you see that? This is from the diagram. And then we substitute PRS. Can you see this? PRS is 55. So we have substituted this value, that is from statement number 3. And then PRQ will be 55 goes the other side. It is subtracted. And so we write it as angle PRS equal to 107 minus 55. That is 52 degrees. And that is our answer 3. Let us look at another question from the same paper. This one is from question 10B. So it is from section 2. This is a choice question. But still we have in the figure, O is the center of the circle and QR is equal to QP and angle ORP is equal to 20 degrees. Find the value of X giving reason. Where is our QR? QR is equal to OP. This is equal to this, and angle ORP, this is 20, and we have to find this. So let us first draw the diagram. Look at the diagram now. QR is equal to OP. So we have QR, that is this one, is equal to OP, that is this one. Now, majority of the times, the circle diagrams can be confusing because they may not be according to the scale. But that should not stop us from getting the answer. So now, what is OP? Isn't it a radius? So, if OP is the radius, then OQ also is the radius. And so, in this triangle, you will see 20 degrees is already given. So, we'll have to link with known, and slowly we have to come towards unknown. So now if this is 20, then this angle over here, ROQ, also will be 20. Why it would be 20? Because this triangle here becomes an isosceles triangle. Alright, now what does this angle become? See, slowly we are moving this side. So how much is this angle? Won't this be 20 degrees plus 20 degrees? So this one becomes 40 degrees. Now this angle is part of this triangle. Now in this triangle, OP and OQ are equal. And so even this angle becomes 40 degrees. Okay. Now can you see that TOP, this angle is the angle which is connected with these three angles. It is not an exterior angle because TOQ is not a straight line. So we have to take X, then we have to talk about this angle. Let us call this angle as A. So X, A, and this is 20. Now TOS is a diameter, so it's a straight line. If it's a straight line, what is the sum of X, A, and this? 180 degrees, correct? And so we shall write over here X plus A plus 20 degrees is equal to 180 degrees. Can we find this A? Of course, yes. This is 40 degrees. This is 40 degrees. So in this triangle, this angle A plus 40 and 40 gives us 180 degrees. So A plus 80 degrees is 180 degrees. How much is A? Isn't that 100 degrees? Now 100 plus 20 and plus this X. All these will add up to 180 degrees. And so we'll have X plus 100 plus 20 degrees is equal to 180 degrees. And so your X is equal to 180 minus 120 means 60 degrees. Did we get that? Now let us see how we write it. Let's look at the solution. You can take a screenshot of this. And as we have discussed over here, exactly the same way we have written this. Now let's look at another question. This question is 2017 ICSE examination question. It is from question number A to B. It is for 3 marks and it is of course from second section, which means it is one of the choice questions. Let us look at it. In the given figure, PQ is a tangent. So we have PQ is a tangent at A. AB and AD are bisectors of CAQ and PAC, and BAQ is 30 degrees. So BAQ has been given as 30 degrees. Prove that BD is the diameter of the circle and ABC is an isosceles triangle. As usual, first we will draw the diagram. Okay, so we have drawn the diagram. Now, BAQ is this angle. This is 30 degrees. I'm writing here 30 degrees. Also, we know that AB and AD are bisectors. AB is the bisector of CAQ, which means this angle and this angle, they are equal. So I'll show them with single ring. This is X degrees, this will be X degrees, okay? Now, AD is the bisector of angle PAC. Can you see that? So this will be Y and this also will be Y. And I'll show these with a double ring. Getting it? All right. Now, let us start thinking. We have to prove that BD is the diameter. So if BD is the diameter, then this angle becomes angle in the semicircle. So this angle should be 90 degrees. Do we have any connection with 90 degrees? Let us check. This is X 30. So this X also will be 30 degrees, right? Now, this full angle becomes 60 degrees. And so this full angle becomes 120 degrees, correct? So each one of these becomes 60 degrees and 60 degrees, correct? So we have this 60 degrees and this 30 degrees gives us this becoming 90 degrees, right? Now if this is 90 degrees, then this becomes the semicircle, which means BD becomes the diameter. So we proved the first part. Now let us look at triangle ABC. I have forgotten to join BC. So let me just draw that fast. So ABC, if it's an isosceles triangle, now isosceles triangles means the sides are equal. Have they given any of the sides? No. So we have to concentrate on angles. Do we know anything about angles of isosceles triangle? Yes, the base angles of the isosceles triangle are equal. So I can see for triangle ABC only one angle here, 30. So this angle also should be 30. Now, how do I connect this angle with 30? This is also 30, this is also 30. Is this angle over here connected with this angle here? Yes. Can you see AQ is the tangent and AB is the chord at the point of contact? And so BAQ angle will be equal to BCA, and that will be the angle in the alternate segment, and that is your 30 degrees. Now in this triangle, this is 30, this is 30. So two angles are 30 degrees each, and so it becomes isosceles triangle, and I'll say that sides opposite equal, angles are equal. So opposite this 30 is BC, opposite this 30 is AB. So we have AB equal to CB, and so it becomes an isosceles triangle. Now let us see how we write it down. So let us look at our solution here. We have written exactly what we discussed over here. Now this was the shorter way of getting things done, but writing takes a little more time. Take a screenshot of this, or you pause this video and write this down, because these are all important ICSE questions. Okay? This is yet another question from 2017 paper. This is question number 9. So this is also from the choice question, second section this is. As you can see this is for 4 marks. In the given figure, O is the center of the circle and angle DAE is 70 degrees. Giving suitable reasons, find the measure of angle BCD. So we have BCD, BOD, then angle OBD, we have to find. So as usual, what we'll do, we will first draw the diagram in order to understand the question better. The first thing that we do over here is draw the diagram and mark what has been given. Only this 70 has been given, which means now we have to mark which are the angles to be found. Angle BCD. So we have BCD, we'll call this as A. We have to find this A. Angle BOD, and that is your B. And angle OBD, that is your angle C. Now as usual, remember, in all the questions, the tips are connect what is known to what is unknown. So now 70 degrees has been given, and that has to be connected with our A. So how do we look at it? Now we have DAE is the exterior angle of this figure. What is this figure? It is the cyclic quadrilateral. And so we have this 70 will be equal to this. What is the reason? Exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Correct? So I'll write this is 70 degrees. Do you know the connection between this and this? Do you know what type of angles these are? This is angle which is subtended by BD at the circumference, and this same arc is subtending angle BOD at the center. And so, is there any connection between this and this? Alright, once you find this, how will you link this with this? What type of triangle is this? Now, you think about all these things and write the solution just now. Put this on pause. I'm giving you time starting now. Check your answer. The first one, this is 70, so this becomes 70. A is 70. So we wrote that exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Then we said that this angle and this angle, how are they connected? Angle at the center that is BOD, is twice angle at the circumference. So we write just that like so. Okay. Then we come to the third part. We have found this. This is 140 degrees. Now we say that OB equal to OD, which is radii, like so. And so this angle and this angle, they will be equal. And we write it, angles opposite equal sides are equal. And then we take this triangle and we say 140 plus C and C. Can you see that? Equal to 180 degrees. And so 2C is equal to 40 degrees. So C becomes 40 upon 2, that is 20 degrees. But that is our angle OBD that is to be found out. And that's how we write our third answer. Did you get that right? Give yourself a nice star. Okay, so understand that the presentation of the work also is important. First, you have to draw the diagram, and in the diagram, you work it out. And once you worked out, write the steps neatly like this. Okay, let us come to question 7 of this year's ICSE paper 2019. And this is question 7, which means again it is in section 2, which means it is a choice question. Let us look at the diagram. In the given figure, AC is the tangent to the circle. Can you see this? AC is the tangent. And angle ADB is 55 degrees. And we have to find X and Y degrees. Give reasons for the answer. Let us draw the diagram and let us see how we connect the known to unknown. So we look at the diagram. The diagram is having this X, this is 55 and this is Y. Now understand that all these unknowns that are there, this X and Y, we have to connect them with this known which is 55. Now because these are angles, we have to look for angles. Can you see AOB is a diameter? So OA becomes radius at the point of contact to this tangent. So this becomes 90 degrees. And so in this triangle, we know this is 90, this is 55. We can find the third angle. And then if we look at this angle Y, isn't this angle at the center and this angle at the circumference? What is the connection between these two? And then once we get this, can we not connect them with this triangle, with this 90 and this Y, which is twice of this 35? So now that we understood that X and this 70 and 90 can be taken as angles of triangle OAC, let us see how we write. Now look at the solution. You can pause it and you can take it down. Write it on your own. It will help you. Can you see how we got that 35 degrees? Then we got Y as 70 degrees. There, we got the answer. All of you got the answer right? We understood well? Okay, let's come to the last question now. This again is from 2019 question paper. In the figure, ABCDE is the pentagon inscribed in a circle such that AC is the diameter. Can you see that? ABCDE and AC is the diameter. Side BC is parallel to AE. BC is parallel to AE and angle BAC is 50 degrees. Find giving reason angle ACB, so we'll call that as A. EDC angle, EDC, so this one becomes your angle B, and BEC, and hence prove that BE also is a diameter. Let's draw the diagram and let us see how it is to be solved. Okay, so we have the diagram ready. Now quickly let us look at what is given. A is parallel to BC, AC is the diameter, and we have to find A, B and C, and we have to also prove that BE is a diameter. Now sometimes you may get a situation like this, but it doesn't matter. You have to prove that BE is a diameter. You do not know if it is a diameter. So even if BE does not pass through O, it's not a problem. So let us look at A. Can you see this ABC is 90 degrees because angle in a semicircle is 90 degrees. Can you see 50, 90 and this A will be angles of this triangle? How much A will turn out to be? 40 degrees, correct? Now let us come to our B. Now can you see that this parallel to this will give us these alternate angles? So if this is A, this also will be 40 degrees, yes? Now can you see this one over here and this one? This particular part, is this a quadrilateral? Yes. And 40 and this B, what are they? They are the opposite angles of cyclic chord. So B will turn out to be 180 degrees minus 40, which will be 140 degrees, correct? Now we got this B. C will be angle in the same segment. Can you see BC is making this angle and this angle? So this 50 and this 50. This also will be 50 degrees. Because this is 50 degrees, this also will be 50 degrees. Why? Because they are angles in the same segment. Now let us see how we write this solution. So let us look at our solution. You can pause the video and you can take it down. We've already discussed the whole thing. See the way the work has to be presented. There. Do let me know if you found this video helpful or otherwise. Thank you for watching.